Hi everyone, it's great to be able to join for ESNEXT Conf. I think we don't have enough context in JavaScript where we get to discuss the future of the platform, the future of the language. It's easy to get caught up in our day-to-day struggles as developers in shipping our products. But if we look ahead to that 5-10 future of the language, there's a lot of exciting areas to work on and a lot of necessary collaborations where we can work together and shape the platform. The talk I'm giving today is on import maps in particular. So how the next step that's coming for our modular workflows in JavaScript, and specifically the complex cases that come up when you try to use them in more advanced scenarios. So the main workflows with import maps are pretty fleshed out, but when you start to hit certain issues in terms of how you apply them in slightly more practical or advanced workflows. My name is Guy Bedford, and I'm a core contributor to a bunch of open source projects, Rollup.js, Node.js, and I'm also the creator of System.js and JSPM. So the sort of workflows that I'm talking about when it comes to generating import maps are things like this. So tooling possibly that's going to automatically generate these maps. Thinking about the difference between production and development workflows. So when you have an import map, you're going to use it very differently in development to the way you're going to use it in production, where you care far more about optimization problems and how you're going to optimize those import maps. Whereas in development, you have the ability to do stubbing or you have slightly more development-facing workflows that are going to swap out modules and allow you to customize your workflows. There's also the question of local versus external URLs. Is that import map going to reference directly on a CDN or not? And when you're doing that, how we're handling things like lock files, integrity, and trust. And it's actually, the workflows are very different to the existing package management workflows that we have with NPM today. So how do those adapt? In a short 25 minutes, I can't actually go into much of these topics at all in much depth. I'm actually going to focus mainly on just a few of these cases and hopefully just to get a few ideas across there. Before I get into these workflows though, it's worth remembering that import maps have quite an extensive history in JavaScript. Perhaps not a very well-known one, perhaps not a very popular one, but they've always been there on the fringes of our JavaScript workflows. And if we go all the way back to 2009, there was this project called Require.js, which is actually, as far as I'm aware, one of the first projects to introduce a mapping system to the browser. So the Require.js loader had this thing called paths config. It also actually had something called map config, which also allowed mapping. And that was always one of the big confusions when learning Require.js, which to use. To be honest, to this day, I still don't know. But you could define these maps and you could say, I'm going to load jQuery from this location and Bootstrap from this location. The examples give you an idea of the timeline as well here. And then you have this require function that is a lazy loading dynamic importing function, just like the dynamic import we have in browsers today. So the workflows with Require.js and the require function are actually very similar to the dynamic import and import maps. And so a lot of this stuff has been explored is over 10 years ago. And in 2012, what I believe was the first JavaScript package manager that actually created this map config was a project called Jam. And the website's still there. You can have a look at it there, jamjs.org. And it was a package manager that you would install a package, so you can see the example on the left here, install Backbone, which itself depends on underscore. And again, you can see the timeline of these examples. It would locate it in your local cache folder, and then it would update your Require.js configuration and set this maps or paths configuration to locate those dependencies. And in the browser, you would just load this jam require, and then you could load your dependencies directly by name without needing to know the URLs and load them lazily, just like dynamic import. And it also had a production optimization option. And this project was really interesting. It was developed by Kaylin McMahon, but it never got any traction. It was well known when it was released, but it very quickly disappeared. And it's interesting to look back at this and think about what were the reasons that it didn't succeed back then. If we had all the technology, how is it different to what's going to happen with import maps in future? And I mean, I have some ideas there, but it's still very interesting why that happened, and what it takes for a certain critical mass in the ecosystem for things to really catch on. But what did catch on, at least for a while, was Bower, which was released in 2012. And with Bower, you were mostly installing packages from GitHub. That was the main kind of workflow. And these GitHub packages would usually be single file jQuery plugins or single file builds that were maybe in the UMD format. So you could use them as global or use them with require. And I think one of the reasons that Jam didn't get so much traction was because with Bower, you would just install these things, and it was fine to reference them by name. You could just load it from the Bower components folder, load the script, include it with a script tag. There was no reason to have automatic management of this when you've only got 5 to 10 scripts on a page at most. So these were the kind of workflows that mostly started to dominate with require.js and without require.js. In 2013, System.js and JSPM released, and System.js was kind of focusing on the problem of how to bridge require.js to the future of modules. So it was actually a very similar loader to require.js, also having map configurations and things like that, but building on top of the principles of the up-and-coming ES module loader, following the same semantics, circular references, live bindings, so that you had workflows that you could write native modules with and run them in the browser. And JSPM was kind of like the jam for System.js, trying to automatically generate those configs when you wanted to run lots of packages in the browser. And it took a whole nother 5 years before we got native import maps for JavaScript, which were finally specified in 2018. A group of Googlers got together and had some discussions around these mapping problems, and put together the spec and proposal for import maps, which is a WICG specification. And it's available in Chrome today under the experimental web platform features flag. And we'll come back to import maps shortly. In 2019, we've got Snowpack, and as far as I'm aware, Snowpack might be one of the first projects to create an import map for JavaScript natively in development workflows, and you can just get going with them. And so, what do the next 10 years hold? And I think one thing that's very clear is that the history of this stuff is, I mean, the timescales that we're dealing with this stuff are actually incredibly long. So you do have to think about the multi-year future. And we've got modules right now. Import maps are sort of on their way. But what will the workflows look like that are adopted as that happens? And one of the assumptions that's useful to think about with this is, imagine we're in that environment in a few years' time, where all browsers have full support for import maps. What do our workflows look like for JavaScript? And how does it affect our tooling and our optimization and our development process? So here's an example of an import map. And you would usually have this in a .import map file, or you would load it directly in the browser with a script type import map. And they're pretty great. They're pretty straightforward. I think most people can look at this and have an idea of what it's doing. You're able to just map these simple specifier names into the URLs that correspond to those modules. And in most cases, managing these import maps manually is probably the best workflow. You just or very specific to the tooling that you're using, or maybe you have an internal tool that's managing your import map. I think the major scenario initially will be just to have very specific tooling that just deals with these very small import maps that do the things we need to do. And so you can write these by hand and maintain them by hand in the browser and have a nice development experience where you're just importing modules by name and you don't have to maintain specifiers. And that's the immediate win. But there's some interesting things that apply to import maps and apply to their generation. And the first one I want to speak about is the exports field. And Node.js has recently shipped support for a exports field in the package.json. And in the design of this exports field, Node.js specifically focused on creating a workflow that would directly complement import map generation. So the exports field looks something like this. It allows you to define the entry points of a package. The dot export is the main, so you can point to your main just like the existing main in your package.json. But then you can also enumerate the individual features of a package. So feature here pointing to feature.js, or it could be any internal path. And it looks very straightforward, but this is actually a very important concept. You can read up in the Node.js documentation. If you go to the ECMAScript modules documentation and the package entry points section, you can read up more about it. But being able to enumerate the entry points creates a well-defined package interface, and it separates the external interface of the package from the internal modules of the package. When you use the exports field, you can't import internal modules. They're fully encapsulated. Only the exports are exposed to consumers of the package. So you get the separation that then has a whole bunch of tooling benefits. For example, in your IDE or editor, you can auto know what the subpaths of a package are because they're enumerated in exports. You don't need to check the file system. You are able to, there's optimization opportunities because we know we don't need, the internal modules can be optimized out as necessary. And they also directly allow for import map generation. So the first thing to note is that using these separate feature exports is actually a best practice for package authoring and package consumption. So if you're creating a new JavaScript package, instead of lumping everything into one big file and relying on tree shaking to magically know how to remove code that wasn't used, it's actually much better to just import features as separate modules. And that way you know that code is not being included that is not being used. And the reason why this is superior is compilers and bundlers, even though they're very good with tree shaking, there are always going to be cases of side effects that they can't detect. Maybe one feature depends on a dependency which has a whole large dependency tree, and you're going to pull in all this code. Now the bundler has to churn through all that code to determine if it definitely needs to be included or not. And all it takes is one line that mutates the global, and it absolutely has to include that. So they're always superior for performance and highly recommended. So if you're doing this sort of thing, what that means is each of those individual exports directly determines the import map. So here is our package.json. When we generate an import map for consuming this package, say it's called package, you would generate an import map that references the main by the package name, and then package feature references the individual feature module. So the exports field directly enables the package imports, and this was very explicitly designed in the Node.js modules process, which was quite amazing that we were able to, as a project in Node.js, think more widely than the project itself. And it's this kind of cross-disciplinary or cross-project thinking that's really needed with modules, because it falls between all the gaps between the different platforms and environments. Another feature of exports is we get the browser condition. So you can actually branch and use a different module for the browser. And the way we define this in the exports field is with an object map that lists the conditions. So in this case, we're going to load main browser just in the browser. Node.js won't load it when you're running in Node. And the same for the feature. And then when generating the import map, we can specifically resolve the browser condition, and you get a browser-specific import map that doesn't load unnecessary code in Node.js. So just like loading features by subpaths is a best practice, because you're definitely only including the code you need and not including code you don't need. This also does the same thing for browser loading, that you're only loading the code you need in the browser and not loading unnecessary Node.js shims that often ends up bloating Webpack configurations today, like buffer shims and fetch shims and things like that you might not even be aware of you're including in your bundle. So I'm going to show a very brief demo now of this kind of workflow and how it can look. And this is sort of a sneak peek of the upcoming version of JSPM. which won't actually be out for quite a few weeks yet. But what this is about is just sharing the ideas and showing how these kind of workflows can look. So let's jump straight to it. So the example I want to give is an example of Preact. And let me actually first show you what Preact looks like. So if I look at the package.json for Preact on unpackage.com, you can see it's got this exports field here that defines, exactly as we've just described, the individual features and the browser conditions for them. So what this means is I can install the variations of Preact into my import map. And so let's give that a go. And the way I'm going to do this with the upcoming release of JSPM 3 is I'm actually going to install Preact compat. I'm installing the subpath of the package directly here. And when I enter that in, it's going to create a import map for me that just includes that single mapping. And the reason why is if I'm not using any other features of Preact, I don't need to have them in my map necessarily. And then one of the things it's done is it's automatically populated the scope here for Preact and Preact hooks. And the reason it's done that is if we go back to Preact, if you look at this compat.module.js file, you can see that it actually depends on Preact hooks by name. So these are best specifiers again. And it also depends on Preact. So it's going to load these as separate modules. So it populated those as well because they were necessary to get it to run. And that's just about it. If I just create a test page, we can load this up. Sorry, let me switch back to my editor. If I create a test page, we can load this up using a import map in the browser. I've got my experimental web platform features flag enabled in Chrome, so it should work correctly. And I'm then going to do a script type equals module, and I'm going to import star as Preact from Preact compat, and then just log it to the console. Very boring demo, I'm sorry. And let's run an HTTP server, and then switching back to Chrome, if I go to localhost, you can see there it's loaded up Preact compat. And if we look at the network tab, you can see how it's loaded it. It's loaded the compat module, and then once it's loaded the compat module, it's loaded hooks and Preact. And so loaded those dependencies, also resolved through the import map. So that's the kind of workflow that can be enabled with exports and directly populating these import maps. Like Jam, these are probably quite future-facing workflows. They're not necessarily workflows that we're going to need initially, but the way that exports field was integrated is something that can apply to all different types of tooling, as I say. The next optimization issue that you might have noticed when I showed that demo was that there was a latency waterfall in loading Preact. So it had to load Preact before it could load its dependencies. So this is what happened. We send a request for Preact, we see it's got these imports, and we're then able to send requests for those separate imports, and then finally it executes the code. And that's a double latency waterfall. It's just one extra round trip latency, but that's still a performance cost. And the thing to bear in mind is that in theory, that latency is unbounded because you can have any depth of packages in a module tree. So this is actually a huge performance issue when it comes to import maps. And HTTP2 is not the solution to this, because if we were to push those dependencies automatically, it's going to ignore anything that was already in the browser cache. And there is cancellation for push, but the cancellation takes too long. The bytes have already been sent by the time you send the cancellation request, because again, we're acting under latency. And WebBundle has similar concerns, and similar solutions are actually being tackled to the one I'm going to suggest now. But again, the HTTP2 push model is not worth thinking about here because of the cache override. When everything's cached in the browser, you want to use what's cached. You don't want to be re-requesting it. You don't want to be sending unnecessary bytes. So the way to do it is preload extraction. You build up the list of modules that are going to be loaded, and you preload them all together on the original page load, and then you kill the latency. If I put this into my example, you would see everything being requested in parallel, and we don't have that latency problem. So this is the comprehensive solution. This is the way to do it. But it is a sort of a tooling problem constructing these module preloads. And there is a problem with it as well, which is that it does not work with lazy dynamic import. So the whole point of using modules like this is that you only want to load code that is needed at the time that it is needed on the page. And when I'm using dynamic import, I'm able to lazy load things, but now I'm going to hit that same waterfall because the preloader isn't being associated with the dynamic import. So it's going to have to fetch, preact, and then see the dependencies, and then fetch them and load them. So there's a preloading problem, and it goes a little bit deeper than just injecting preload tags. So the idea is that if we could hint at the module graph to the browser and tell the browser what modules are going to be loaded when, then we could work with the browser preloader and sort of design for the browser preloader in our workflows to try and help it create an optimal loading profile. And so there's a proposal that I'm trying to get together here called a dep cache. It's available on GitHub import maps extensions, and it's a bunch of proposals for improving import maps. And the idea with dep cache is that you could just populate another field in the import map, and you could specify that when I load preact compat, I'm also going to need to load these modules statically at the same time. And just that information tells the browser everything it needs to understand the dependency graph, and it can then request them in parallel. There has been some discussion that maybe this should be something that's more general for the web, works across all types of web content types. But one of the reasons why I think this is a specific problem for modules is because it's the dependency tree that is itself potentially unbounded. With CSS, you don't have the possibility of loading like lots of different versions of CSS packages 10 levels deep. This is specifically a modules problem that we have in JavaScript, where you get these depth problems. And these are problems that only come up later on in the workflows. They don't come up with simple trees, but these are problems that will come up in future. And if we don't work on standards for them now, they're going to be problems in a couple of years down the line. Here's another example of a tweet recently from Evan Wallace, who is the creator of ESBuild, or actually the creator of Figma, but he's been working on JavaScript optimization recently. And he put an example together of a multi-megabyte module that had imports at the top. And the full multi-megabyte module is loaded before any of those imports are preloaded. So the browser isn't doing as much preload optimization work. And as usual, solving these problems is going to fall to userland. And we're likely going to have to start coming up with bundling techniques that cater to these preloading problems specifically and start to solve for them. So those are some of the ideas that I can get into this time frame here, but hopefully just to give you some food for thought. But there's a whole bunch of scope for collaboration and working together. And I think starting from solving your own use cases, just using things in the simple way that gets your applications done, but share your solutions, join in the discussions, get involved in the ecosystems, because we're collaboratively shaping this web. And it's a platform that we have a unique opportunity to be able to improve together. So when you do hit up against these problems in your daily workflows, think how should this be solved more generally? How can we get involved in trying to move things forward? And a comment on a spec repo can have a lot more power than you might think. So thank you everyone for listening, and I believe we're going to do some Q&A, so I'll be around for a while.